Hello, Florian, Luca, and me, Emily. We're the team behind Best AS, and today I want to talk about a massive problem in our energy transition and how we want to solve it by turning wasted energy into community wealth. Right now, France is suffocating under renewable energies. In 2025, an estimated 3 terawatt hours of wind and solar energy was curtailed during negative price periods. And to put this into perspective, that is up from just 0.6 terawatt hours in 2023. But why is this happening? We're facing severe grid bottleneck. While it takes 1 to 5 years to build renewable energy projects, building new transition lines takes 15 years. And this visible waste, combined with local grid saturation, is creating a huge political threat. In fact, it recently led to a near-miss parliamentary moratorium on new wind and solar projects. And the bottom line is, we're producing more clean energy than we can transport, and we need a solution today. Our solution is local storage combined with citizen ownership. And we tackle this from 3 angles. First, we deploy standardized 1 to 2 megawatt hour modular battery blocks exactly where the distribution grid is congested. Second, we use an energy management system that absorbs surplus energy during negative prices and dispatches it during peak demand. Third is our secret weapon, our ownership. Our projects are financed through a citizen energy community SPV, so locals co-invest and earn direct dividends. And by making citizens infrastructure co-owners, we effectively turn local not in my backyard into yes in my backyard. And we have found a highly defensible niche in a rapidly scaling market. While establishing competitors like TAG Energy, what are trying to construct a massive 240 megawatt scale projects that face significant delays in permitting processes to access the national grid, we take a different approach. We build agile neighborhood scale assets, and by connecting directly to distribution edge congestion points, we completely bypass national transmission queues. And the demand is explosive. And Enedis local flexibility procurement grew 10 times in a single year, reaching 446 megawatts in 2024. This brings us to our unit economics, which deliver infrastructure scale with tech-like paybacks. A single block requires a capex of 500,000 euros and an annual opex of 50,000 euros. And through Enedis reservation payments, system services, and merchant arbitrage from charging negative prices, we generate an estimated 345,000 euros in annual revenue for 2027. This means a single block completely pays for itself in just 1.7 to 2.4 years. So we have the technology, the strategy, and the operations ready. Join us in building the localized, citizen-owned grid of the future. Thank you.
France has one of the cleanest electricity grids in the world. In 2024, over 95% of French electricity came from low-carbon sources. And yet, France wastes approximately 4 terawatt hours of renewable electricity every single year, enough to power 1.5 million homes, simply because the grid cannot absorb it fast enough. This is curtailment. Wind turbines are switched off, solar panels are disconnected, and at the same time, France spends over 64 billion euros a year importing fossil fuels it doesn't need. The problem isn't that France has too much renewable energy. The problem is that demand isn't flexible enough to follow supply. That's what we fix. We propose the National Flexibility Pact, a 4-year intervention focused on Hauts-de-France, France's most wind-rich region, and the territory where curtailment is most severe. Instead of building new turbines, we make existing demand flexible enough to absorb every megawatt hour the grid would otherwise discard. We do this through 4 pillars. Smart EV charging. 200,000 electric vehicles in Hauts-de-France charged when the wind blows, not when everyone gets home from work. That's 0.6 terawatt hours absorbed. Industrial demand response. 120 heavy industrial sites in the Dunkirk corridor, equipped with automation systems that shift their highest energy processes to coincide with wind peaks. 1.1 terawatt hours. Power to heat. Surplus electricity heats homes and stores thermal energy in insulated tanks, displacing gas boilers. 0.7 terawatt hours. And green hydrogen. A fleet of electrolyzers totaling around 500 megawatts across the Dunkirk industrial zone, anchored by a first 200 megawatt unit at Lune Plage, running precisely when the grid has surplus, producing clean hydrogen for heavy industry in the Dunkirk corridor. 1.6 terawatt hours. This isn't theoretical. Denmark already achieves near zero wind curtailment through exactly this kind of sector coupling. Great Britain's Demand Flexibility Service signed up 1.6 million participants in its first winter. These are the benchmarks we're replicating. Our 4-year plan is phased and measurable. By year 3, 2.5 terawatt hours are absorbed, and the first 200 megawatt electrolyzer at Lune Plage is operational. By year 4, we check 3 conditions: curtailment below 0.5 terawatt hours, 3.5 gigawatts of certified flexible demand, and community approval above 55% in priority communes. If all 3 are met, and our sensitivity analysis shows they are robust even under partial deployment, the moratorium is lifted. The investment is 1.1 to 1.5 billion euros over 4 years. The return is break-even to plus 340 million euros, before counting the 800 million to 1.2 billion in regional economic activity that follows when new renewable projects restart. France's moratorium is not a dead end. Managed correctly, it is the catalyst for a smarter, more resilient energy transition. We show you exactly how to get there.
Bref. So I was looking over at energy data because, well, I guess that's what I do for fun now. And I noticed something strange. France is producing more and more renewable electricity, which is great, but sometimes we produce too much. Wind turbines spin, solar panels produce, and the grid goes...
Sorry, buddy. We don't need that.
Bref. 4 terawatt hours of renewable electricity could be curtailed in France.
That's awful.
So with 3 friends, we started looking for solutions. First idea is store the electricity. Batteries, hydrogen, pumped hydro, even thermal storage. Basically, giant electricity piggy banks. The problem, they need infrastructure, investment, and time. Second idea, absorb the electricity. Electrolyzers, electric heating, flexible industrial demand. Basically, convincing machines to say,
I'll take it.
But again, industry has to invest, and technological maturity makes it unsure. And then, Kemi had an idea. I think Switzerland is phasing out nuclear and will need to import new electricity. So we checked the data. Cross-border flows, interconnections, demand projections, electricity prices. We built a model, we ran simulations, and we drank a lot of coffee. Bref. Turns out France could export from 2.6 to 8 terawatt hours more electricity per year using interconnections, which means something simple. Instead of curtailing renewable electricity, France could sell it to neighbors who need it. Italy, Germany, Switzerland, Belgium. Countries that import electricity anyways. So why is this solution interesting? First, it already exists. The interconnections are there. Second, it generates revenue. Instead of wasting electricity, France sells it. And third, it helps Europe decarbonize, because French renewable electricity ends up replacing fossil generation elsewhere. And fourth, the money can accelerate the real long-term solutions by funding more storage, more grid flexibility, and more industrial electrification. But of course, exporting electricity won't solve everything. Some days the grid will still be congested. Some hours our neighbors will also have too much solar. There will still be some excess electricity, and that's where storage comes in. New batteries could store the remaining surplus, then release it later, in the evening, during peak demand, or when interconnections are less congested. And here's the interesting part. Because electricity can already be exported, investors know the energy will always have a market. If the grid is free, export it. If the grid is congested, store it. This reduces the risk, which means private investors are more likely to finance new storage capacity, and that helps absorb the remaining surplus even faster. So exports don't replace storage, they unlock it. Bref. Exports solve the problem now and help finance the solutions for tomorrow, which also means something important. The renewable curtailment problem shrinks faster, which means the moratorium on renewables can be lifted earlier and more safely. More renewable energy, less waste, more revenue, and a more flexible European grid. With our export-first solution, France stops wasting green electricity, Europe gets clean power, and the transition moves faster. Bref, we hope you'll choose export first.